In this example, we'll be going through the individual GWAS enrichment analysis. Upon selecting this option, you will see the graphical image below has changed. It is changed to highlight the different steps that are involved in this process, but also the different order that you can conduct the analysis. Upon selecting Run Pipeline, you'll be brought to Step 1, Marker Dependency Filtering. Before we go through the input files and parameters, I wanted to point out the left-hand sidebar. Here you will find your session ID. We highly recommend to copy the session ID for your records by clicking the ID. As you can see, it's now been copied successfully to your clipboard. If you already have a session ID and would like to load a previous session, you can input your ID here. Additionally, for user convenience, the graphical sidebar will show you what step of the MergeOmics pipeline you are currently conducting or what steps you have completed. So in this case, we are at the MDF stage. Additionally, for every step in the pipeline, we provide a Click for Tutorial button where you can see descriptions of the files and parameters. As mentioned, we're at the MDF stage, and MDF is a process for mapping and filtering or correcting for marker dependency. If you don't need this step, you can select the Skip MDF option. However, we highly recommend to not skip this step, as if dependency among markers are not corrected, spurious results may be generated. The first step is to upload or select your marker association file. If you choose to upload your own association file, please use the Upload Your Association data. It's extremely important to make sure that you format your tab delimited text file in the correct format, where you will need two headers or two columns, one with marker and the other with value. Marker can be your RSID or chromosomal position, and the value should be a negative log 10 p-value. It is important to not use your raw p-value because in this case, larger values signify higher association strength. We also, for convenience, provide numerous disease GWAS options that you can select for. For this example, we will use the sample human GWAS. The next step is selecting or uploading the marker mapping file. If you choose to upload your own marker to gene mapping file, please ensure to follow the sample layout again, as can be seen here. With any data upload containing genes, we provide the option to convert Entres IDs to gene symbols and ensemble IDs to gene symbols also. For convenience, we provide three major types of mapping options, including distance-based mapping, tissue-specific EQTLs, so expression quantitative trait loci, as well as splicing QTLs. To help with interpretability, we suggest to select just one form of mapping to preserve tissue specificity. However, you can select up to 5 mapping options to be combined. For this example, we will use the GTEx adipose subcutaneous EQTL. Finally, your last input file is the marker dependency file, and this is to filter for linkage disequilibrium. You can see here that we provide 50% and 70% filtering for 26 populations. 50 means that SNPs with 50% correlation or above will be filtered out. Also, there is a 3-letter code which represents a given population. If you select here, you will come to this page, which will show you in more detail what these codes represent. Again, if you would like to upload your own marker dependency file, you must follow this format. For this example, we will select CEU LD70, which is a European population. Finally, you can select the percentage of markers to include in your analysis. The default is 50%, so the top 50% sorted by association strength. But perhaps for smaller studies, you may want to increase this to 100, or for larger studies, maybe decrease to 20%. For this example, we will stick to the default. When you click Review, you will come to the Review Files page, where you will see the files that you have uploaded and the parameters that you have set. You'll here will have the ability to enter your email address, and we highly recommend that you do so and click the Send Email option. When you select Run MDF, you will then get an email notification that you have started this part of the analysis, and you will also receive an email when this analysis is completed. We also provide a click to see runtime log. On completion of step 1 or marker dependency filtering, you'll be brought to the Download Output Files page, where you can download each result individually or collectively using the Click to Download All Files in Zip folder, which we highly recommend for you to utilize. To continue with the analysis, you will select the Run MSEA Pipeline button. Here you will see the left-hand sidebar is updated to show you the MSEA stage and have completed the MDF stage. Again, we provide a Click for Tutorial button, which provides further information on each of the parameters for MSEA and the values that we would recommend for you to utilize. Here, the type of file to upload or select will be the gene sets file. If you do choose to upload your gene sets, please ensure that you format your file correctly to have 2 columns with the heading module and the other gene. We again provide a gene identifier conversion to convert Entres IDs to gene symbols and ensemble IDs to gene symbols. An added option is to provide gene sets description file, which can provide further context or description to your module names. You'll need to format your file with 3 headers, module, source, and description like this. But again, this is completely optional and not required. Beyond the upload option, we provide various canonical or knowledge-based pathways that we have collected, as well as tissue-specific co-expression modules that can be utilized. In this case, we will use the KEGG pathways. Next is to select the parameters for MSEA. Again, we provide the tutorial that can give further information into this, and we recommend to stick to the default settings unless you've gone through the tutorial and feel that the parameters can be tweaked to better suit your data set. Some of the more important parameters include the permutation type. We provide 2 permutation types, one being gene and the other being marker. For GWAS analysis, we highly recommend to use the gene permutation, as this corrects for multiple SNPs mapping to the same gene, which may bias the analysis. If you do choose to use the marker option, which is a more lenient statistical analysis, please interpret with caution. Another important parameter is the min module overlap allowed for merging. This will allow or remove redundancy by combining or merging pathways with similar gene sets or functions. Our default setting is to combine at a 33% overlap. You can choose to be more strict or more loose with this parameter, depending if you would like to merge more or merge less. The number of permutations for exploratory analysis, we would recommend to utilize 2,000, but for more formal analysis, we would recommend to use 10,000 permutation. Finally, the MSEA to KDA export FDR cutoff is an important parameter, as this determines at what significance threshold the module should pass to be input into the next step, so the key driver analysis or KDA. We recommend 5% for formal analysis, but for more exploratory analysis, like in this case, we would recommend to use the default setting of 25%. Upon having gone through all of your parameters, you can click to review, where you'll have the last chance to go through each of the files that you have uploaded and the parameters you have selected to ensure that they are correct. We highly recommend that you enter your email and send email, and then you can run the MSEA pipeline, where you will receive an email confirmation that the analysis has started, and you will receive an email confirmation that the analysis has been completed. Here you can also see a click to see runtime log, where you can see the analysis being conducted in real time. Upon completion of the marker set enrichment analysis, you'll be brought to the results page, where you'll be able to download each result individually or collectively using the click to download all files in zip folder option, which again, we recommend to utilize. The two major sets of results are the unique MSEA results, which are non-merged, where you can see further information here described, and then the merge module results files. Again, the merge module results files are based on this parameter, min module overlap allowed for merging, which we have set at a 33% threshold. If it reaches this threshold, they will merge, and if it doesn't, they will not merge and they will stay unique. For convenience, we also provide a results table below where you can see the module ID or pathway name to be most significant, which in this case is PPAR signaling pathway. You can see the p-value, the FDR value, the description for where these file names have come from, the top module genes within this pathway, the top markers that are associated with these genes, as well as the module top association scores. If you're interested in a particular pathway, you can type in search and see what the result was. As mentioned, we did provide an overlap threshold for merging modules. If modules were able to merge, they will have merged on this table. If not, they will stay unique like these. An example of a merged module would be this one, where you can see the comma and 2 dots. And if you want to see what pathways have merged, you would check the overlap setting to see which names have merged. Again, you can see the number of genes that are in the pathways, the number of markers that are associated with these, as well as the merge module p-value. To continue with the analysis, you'll have two options. You can choose to go to the weighted key driver analysis pipeline, or you can utilize the MSEA results directly for drug repositioning. For this example, we'll go to the run WKDA pipeline. Upon completion of the marker set enrichment analysis, we have selected to continue with the weighted key driver analysis instead of going through to the MSEA to PharmOmics option. This can be seen in the left-hand sidebar, where you can see we have successfully completed the NDF step, the MSEA step, and are now at the KDA step. As in other steps, you can see that there is a click for tutorial option where you can see further comments and insights into the different files to upload and the different parameters to select. If you would like to upload your own network, please ensure that you format it correctly to follow the sample file format with 3 columns with head, tail, and weight. Alternatively, you can select from the pre-made networks that we have on our web server, which include Bayesian networks, which are tissue-specific or combined, which are gene regulatory. We also have gene regulatory giant networks that are tissue-specific, Phantom 5 transcription factor networks, as well as protein-protein interaction networks from the string database. In this case, we will select and continue with the Bayesian adipose network. The reason for selecting this adipose network is because we selected adipose EQTLs for mapping. By selecting the adipose network, we are now truly being tissue-specific in our analysis, which may help with interpretability. For the parameters of the weighted key driver analysis or key driver analysis, the first one is the search depth. This determines the search distance used to define the key driver's local network neighborhood, where 1 refers to 1 connection away, 2 refers to 2 connections away, and 3 connections away. We'd recommend to utilize a search depth of 1. You can increase this to 2 or 3 for more sparse networks or for smaller input genes. Edge type is for the user if they would like to consider directionality. If you do not want to consider directionality or do not trust the reliability of your network's direction, you can select undirected. The min hub overlap is the ratio threshold above which hubs will be considered co-hubs. Here we would suggest to utilize the default value of 0.33. Finally, the edge factor determines whether you would like to consider the degree of influence of the weights, where 1 would be full influence, 0.5 would be partial influence, and 0 would be no influence. If an unweighted network is uploaded, users should use 0. As before, you can see that we have uploaded our files and we have selected these options for parameters. Again, we would suggest that you utilize your email and then you can run the key driver analysis. On completion of the key driver analysis, you'll come to the results page, where you'll be able to download each of these results individually or collectively using the click to download all files in the zip folder. Here you will come to, for convenience, a table which describes the modules, the key driver of that module, the p-value, the key driver's FDR, number of genes in that module, the number of genes in that subnetwork of the key driver, the module and subnetwork overlap, and the fold enrichment. You can also search for genes of interest to see their significance, as well as the pathway that they're associated with. After this, you can continue the analysis to go to drug repositioning using the PharmOmics pipeline, or you can display the key driver analysis network. In this example, we'll go forward to display the key driver subnetwork. Upon selecting the Display KDA subnetwork button, you'll be redirected to a new tab. This new tab will provide the visualization of your network. You'll have the ability to download the JSON file, take a screenshot of the graph, but you'll also have a legend here that will signify what each of these shapes and colors represent, where the diamond shape signifies a key driver node, and the circular shape represents just a given node. The color is important as this will signify if it is a non-module member, as in the case of the small gray node, or part of a module, signified by one color. If it is part of multiple modules, then it will be multicolored. The key driver border color signifies the module that the key driver is a top key driver of. The colors represent the pathways that they are associated with. If you would like to change the layout of your given network, you can manually do this by selecting the nodes and placing them in a position desirable to you. Or you can use this active layout option, where you can select different forms of layouts, such as the concentric layout. Previously, upon completion of the MSEA analysis, we fed our results directly into the WKDA. However, this time we'll be using the MSEA results to feed them into PharmOmics for drug repositioning. To do this, you can select the Run PharmOmics pipeline. This will lead you to step 2B, PharmOmics. Here you'll be able to select from two different drug repositioning analysis options. 1, overlap-based drug repositioning, and 2, network-based drug repositioning. In this example, we will go through overlap-based drug repositioning. The second column that you can select from is the modules one. You can select modules based on significance threshold or select specific modules. To select for significance threshold, you can use the all modules from gene set. We recommend to use an FDR of less than 0.05, but you can adapt this to be the p-value, or you can also adapt the significance threshold. To select specific modules, you will select this option, and you can select the modules of interest. Here we will use all modules from gene set. Finally, you can select genes. You can select all genes from the original gene set, or only genes derived from your association data, so originally derived from your original GWAS. Here we can then click to review, where we will see the parameters selected. We can also upload our email so that we can get notified about this job completion. And then we can run the overlap-based drug repositioning. Here we can see it is running, and we can see the percentage of completion at this stage. On completion of the PharmOmics overlap-based drug repositioning, you'll be able to download output files, which include your drug repositioning results, as well as the genes used for repositioning. For convenience, we also provide a summary table showcasing the database that the drug information was derived, the method, the drug, the species that this information was derived from, the tissue it was derived from, the type of study, the dose, the treatment duration, the GWAS score, overlap score, the odds ratio, as well as p-value and within species rank. Upon completion of the key driver analysis last time, we chose to display the key driver subnetwork. In this example, we will go through inputting the key driver results into PharmOmics. To do this, you will select this button. Upon selecting this button, you'll be led to Step 3B, PharmOmics, where you'll have the choice between selecting overlap-based drug repositioning or network-based drug repositioning. We will select network-based drug repositioning. Here, you'll be able to select a network or upload a network. In this case, we will use the sample multi-tissue network. We also have the option to choose from human or mouse. In this case, we will select human as our data is derived from humans. Here you can select specific genes and modules from the subnetwork to run drug repositioning analysis. You can select all genes from the subnetwork, all genes from input modules in the subnetwork, genes from specific modules in the subnetwork, and significant key drivers that pass an FDR of less than 0.05. Here we'll use all genes from the subnetwork. You'll be able to click to review, which will show the custom network's been selected, the species, the module and gene selection, and again, you'll be able to input your email address. We can now run the analysis. Upon completion of the network-based drug repositioning analysis, you'll be able to download your output files by selecting the download options here. You can also see in this table the drugs, the species that those drugs were tested in, and the tissue. In addition, we provide the z-score, the rank, the p-value, and network files that you can download the edges and the nodes. Additionally, you can display the network by selecting any of these links. Upon selecting the display network option for your given drug, you'll be redirected to a web drug network visualization, where you will see your input genes are highlighted in red, and your drug genes are highlighted in blue. If a node is both an input gene and a drug gene, it will be split color like so. You'll be able to manually manipulate this network by selecting the nodes and moving them. You can also download a JSON file. You can take a screenshot of your graph. You can also change your layout by selecting these options like so.